Hi my dear students. So far we have learnt about the basics of maths. I will be taking the topics as and when the demand comes to me. So somebody asked for the organic chemistry, so I am taking class 11th organic chemistry, some basic principles of organic chemistry. So let's start with it, students. So I am starting with the basics of it today, and you can also put your request which topic you want me to take next. So students, we have already learnt in covalent bonding, in chemical bonding, that what are sigma and pi bonds, right? When the atomic orbitals, they overlap end to end, it is a sigma bond which is formed. When they have the lateral overlapping, or I would say sidewise overlapping, then it is a pi bond which is formed. But when we talk about the organic chemistry, in organic compounds, how do we get to know that which is a sigma bond and how many are the pi bonds? Then here is a way to go for it. For example, if they ask you that in methane, I think you have already learned in class 10th, methane has a formula CH4. So if you have a single bond, then it is your sigma bond only. So you can see where here we have 4 sigma bonds, and there's all the bonds which are there are the single bonds, thus all the 4 bonds are my sigma bonds. Now if I have ethene, so the formula is CH2 double bond CH2. Now again this is single bond, so it's a sigma bond. Here again it's a sigma bond. Here again it's a sigma bond. Here it's a sigma bond. Here one is a sigma bond, but now the second one is your pi bond. So in all I can say I have 5 sigma bonds and 1 pi bond. Let's take some more examples. CH H Now if I have a compound CH2 double bond C double bond O, again you have to find out how many single bonds are there and how many double bonds are there. So in this is a sigma bond, this is a sigma bond, this is a pi bond, this is a pi bond, this is a sigma bond, this is a sigma bond. So in all I can say I have 4 sigma and 2 pi bonds. I hope students it is clear. Let's take another example, CH3 C triple bond N. In this, can you tell me? I will give you the answer. Quickly try it and tell me. So yes, you can write it as this. Then you have triple bond N. So these two are your pi bonds. This first one is a sigma bond. This 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 is again a sigma bond. So how many are there total sigma bonds? 1, 2, 3, 4, 5 sigma bonds, and again 2 pi bonds. I hope it is clear, students. So let's move now how to write the structures of the carbon compound. Dear students, you can represent the structure of carbon compounds in 3 different ways. First is writing structural formulae. For example, if I say ethene, it is simply this. So this is my structural formula. Okay. If I say this is ethene, right? Okay. If I say ethanaldehyde, so it is CH3 CH double bond O. Okay. Now again this is ethanaldehyde. So if you write this in the structural formula, you have to write all the bonds like this. You have to represent all the bonds in order to show the structural formula. So this is the correct structural formula because here CH3 is condensed. I will come to the condensed formula after this. Now if I ask you how many sigma in this pi bonds are there, so 1 sigma, 2 sigma, 3 sigma, 4 sigma, 5, 6. So 6 bonds are sigma bonds and 1 pi bond. So wherever you have a double bond or a triple bond, we will have 1 sigma bond, and after that you will have the rest as the pi bonds. I hope it is clear. Let's move to the condensed formula now. Now in the condensed formula, second is the way which is called as condensed formula. In this now you have to condense, that is you don't have to, it is a very time consuming process to write the structural formula of any compound, right? So in condensed formula we don't represent the bonds there. So if I have to represent ethene here, if you remember we did ethene like this, right? So in this case if I have to write simply the condensed formula, I will write for ethene as CH2 CH2. So without the bonds I am writing it. Is that clear? Similarly, if I ask you to write for ethanaldehyde, the formula, condensed formula will be CH3CHO. So here you don't have to represent the bonds, no bonds. So it's a easier and a simpler way to go for it. Next is bond line presentation. In this, students, the point of intersection of two lines basically represent my carbon atom. So you have to write ethene. You know ethene is like this. We have a double bond here. Now you simply write this and a double bond. So here these points or the end points here are representing my carbons, and we don't have to write the hydrogens with this. So hydrogens we don't write. Thus the bond line presentation of ethene becomes simply a sign like an equal sign as I have drawn here. I'll redraw it. This. Okay. If I have to draw for ethane, it is simply like this. If I have, this is now ethane, okay, which is simply, we have a carbon here, we have a carbon here. Rest bonds you can write with the number of hydrogens. Just to make the valency of carbon as 4, fulfill its valency, you will write like this. So simply representing this as like this means the bond line presentation for ethane is simply a straight line like this. If I have something like this, then wherever these points are, these intersection points or the end point, they are carbons. So it is this, this. So how many carbons we have? 4 carbons. Now write the hydrogens to make the valency of carbon as 4. So this is the structural formula and this is the bond line presentation. I hope it is clear. So this is my butane, right? This is the structural formula of butane. If I ask you to write the condensed formula for butane, how will you write? Condensed formula will be CH3, CH2, CH2, CH3. That's it. No bonds, no lines. Here it is only the bonds which are being represented, no hydrogen, no carbon atom. So this is the bond line presentation. I hope we are clear, students. If you still have any doubt, you can come to me or put it in the comment section. We'll do it. Thank you and have a nice day. Bye-bye.